equilibrium. So classical thermodynamics mostly deals with systems in thermal equilibrium. Non-equilibrium thermodynamics and statistical mechanics is hard, but important. Okay, and these are still subjects under research. So thermal equilibrium means that when is a system under thermal equilibrium? So a system is said to be in thermal equilibrium if its macroscopic, variables or parameters, or let me just rephrase this. If the macroscopic parameters, specifying its state are no longer changing with time. Okay. So for example, what could be this macroscopic parameters? It could be pressure, it could be its volume, it could be its temperature, right? So such a system is said to be in equilibrium. So note that equilibrium doesn't mean that the molecules or whatever that is making up the stuff, that they are not moving. We know that, for example, for gases, even when the pressure, volume, temperature are constant and in equilibrium, the gas molecules are still whizzing around, right? So we are talking about macroscopic parameters. Okay, so this is what it means to be, for a system to be in thermal equilibrium. Now we have to, before we formulate the 0th law of thermodynamics, let me just tell you what do we mean when two systems are in thermal equilibrium. Okay. So two systems. So now we are just going to talk about with gases, say, system A and B, with, say, their states, specified by, say, P1, V1, and, say, P2, V2, are brought in thermal contact. What does it mean? That means that we take these two systems and we join them up by a diathermal wall, right? So they are in thermal contact. So generically, once you bring them in thermal contact, these values P1, V1, P2, V2 will change in time. If for some reason they do not change with time, they remain static, then we say the system A and B. So if, say, P1, V1, and say P2, V2 do not change, then we say that A and B are in thermal equilibrium with each other. Okay? Great. Is it clear?
Yes, sir.
All right.